Hello everybody, welcome. Let's get started with the shape batcher. So the purpose of the shape batcher is to give us the ability to quickly and efficiently render all kinds of arbitrary shapes. So for example, lines, circles, rectangles, polygons. Let's go ahead and open up Visual Studio, get back to our code. The shape batcher is going to work by having two arrays. We'll have an array of vertices, and in fact we can draw this right here. The shape batcher is going to work by having two arrays. The first array is going to define the vertices of each shape. So over here we'll have the vertices, and then the next array is going to have the indices that will define the triangles. We'll just list each vertex and then each index over here and send all of these things to the GPU once we've defined all of our shapes. We can do an example of that. So if we want to draw a rectangle, we're going to have 4 points, and the lines will look like this. And the graphics card will only understand if we send it triangles. We're going to break every shape that we create into triangles. You can break a rectangle into two triangles. First of all, the vertices will look like this. We'll have vertex A, B, C, and D. In the vertex list, we're going to send A, B, C, D. This will be vertex 0, 1, 2, 3. We have to have an index list that will define what the triangles look like. So for example, the first triangle is going to be A, B, C. And I'm going to use a winding order of clockwise. Everything will look like this. So we'll have the index list over here that will indicate how to draw the triangles. And so the first index list will point to where the vertices are in the vertex list over here. The first one will be 0 because we're going to draw a vertex 0. The next one will be vertex 1 because that's B. And then the last one will be C, which is vertex 2. That will define the first triangle. Now we need to define the second triangle. We'll start with A and go along this direction like this. The next triangle is going to start with A again, so we're going to go back to 0. So we'll put 0 here. Then we're going to go to C, which is vertex 2. And then we're going to go to D, which is vertex 3. Okay. And so now the graphics card has everything it needs to know how to draw this rectangle. Now let's say we want to draw another rectangle. And so down here, we'll just pretend we have, so we had A, B, C, D, we'll say E, F, G, and H. And so now we're going to have 4 more vertices added to our list. Let's do 5, 6, and 7. The first vertex in 4 will now be E, F, G, and H. Our index list will have to show it where these new triangles are going to be defined for this shape. Our first index is going to be E, which corresponds to vertex number 4, F, which is vertex number 5, G, which is vertex number 6. So I'll divide this by triangles. So there's the first triangle, second triangle, third triangle, and now we need a fourth triangle. So the fourth one's going to start with E, which is number 4. Then we're going to go down to G, which is vertex number 6. And then we're going to go over to H, which is vertex number 7. And you'll notice every 3 indices here defines a new triangle. The number of indices in the index list will always be divisible by 3. If it's not, then we don't have the correct number of vertices in this list, and we probably need to have some kind of error message indicating that this is wrong. And we can keep adding vertices and indices to each one of these lists to draw as many shapes as we want. And then when we are done, or we've reached the maximum number of vertices and indices that we want to allow per batch, we're going to send it all over to the graphics card at once. So over here, next thing in the graphics class, let's add the shape batcher. And I'm just going to call this shapes. This will be, there we go. Bring in the namespaces for MonoGame. Let's create the constructor. I'm going to pass in a reference to the game class. because I'm going to use the reference to the game class to give me access to the graphics device. Let's save the reference to the game class. And we'll just make sure we don't get a null reference. Okay. Now, we need two arrays. The first one is going to contain all the vertices. And the vertices are going to have two parts. They're going to have a position and they're going to have a color. Let's bring in the vertex position color. And we'll make an array of these and I'll just call it vertices. And then the other one is just going to be an array of integers that will contain the indices of the triangles. Okay, so let's create the vertex list. And in here we'll come back to that. We're going to have to create the maximum amount allowed for this list. Indices, same thing. Just make some constant integers. So max vertex count is going to be, so right now I'm just going to pick an arbitrary number. I'm just going to say a maximum per batch of 1024 vertices. And then the max index count is going to be the max vertex count times 3. Now we have the location where we're going to store all of our indices and our vertices. Next, I need to keep track of the current vertex count, and it'll just be a simple integer that has the number of vertices. This will count the number of vertices in the current batch. Next, we're going to record the index count of the current batch. And I'm going to make one more that just records the shape count, and it'll just be how many shapes we're drawing in this batch. They will just start out as 0. And let's make one more Boolean that will determine if we've started batching or not. That'll simply be is started, and that'll just tell us is the batch started at this time. And we'll start out with is started to false. Alright, let's begin the batch. Let's end the batch. We need a flush function. Flush is the function that will take the information from these two arrays and send it to the graphics card as triangles to draw. Here we can say is started to true, started to false. If this was never started, let's throw an exception. Okay. Same thing for begin and end. Let's check to make sure it's started. So if we call begin, but it's already started, we want to throw an exception at that. Okay. And if we try to end and it's not started, let's throw an exception for that. There we go. We also want to, once we end batching, we want to flush. Inside the flush function is where all of the real drawing is going to happen. All of the draw commands are simply going to set up these vertex and index arrays with the information that flush will need to draw. Alright, so the first thing, let's try and draw a simple axis aligned rectangle. So we'll have a draw rectangle. This is going to take an X, a Y, a width, and I'm sorry, a width, a height, and a color. So now we have all the information we need. Get rid of that. There we go. To draw a rectangle. Before we actually allow this command to continue, we want to make sure that batching has started. Let's make a function in here that will just check to make sure we've started batching. This is going to be called ensure started. And actually we can just take, so let's take this one at the end here. We'll cut that, put it in here and say, all right, if batching is not started, then throw the exception that we haven't actually started batching. All right, and so now we can just put that in here for the flush command, ensure started, and same thing for the end. Actually, end will take care of that inside the flush command, so that's all good there. And begin has that all taken care of up there on that one. Okay, so now inside each of our draw functions, we're going to want to ensure started, and then we also want to ensure that we have enough space inside of our arrays to draw more objects. So we can keep calling this draw rectangle and it'll keep adding more information to the index and vertex arrays. So we need to check to make sure there's actually enough room in those arrays to add more information. So I'm going to make one more function called ensure space. And we're simply going to pass in an argument saying, okay, here's the vertex count and the index count that we want to add to the array. And this will ask the question if the current vertex count, and actually we should probably change the names of these. So this will be the shape vertex count and the shape index count. If the current vertex count plus the shape vertex count is less than or equal to the vertices list length, or greater than is what I want to say. If it's greater than, we want to flush the data. And again, we need to do the same check for the index array as well. So if the current vertex count plus the new vertices we want to add is going to be greater than the size of our vertex length or list, then we need to flush the data and start over. Same thing with indices. If the index count puts us greater than the amount of the index list, then we need to flush the data as well. There's one more thing we have to check for. If the information being sent in is just altogether greater than the total amount that we allow here, or the total size of the list, I'm just going to throw an error and not even allow it. Let's make a check if the shape vertex count is greater than the vertices length. I want to throw a new exception saying maximum shape vertex count is, and then we can just do this, and let's put in the vertices length. And we'll do the same thing for the indices. So if the index is greater than the indices list, we're going to throw the same exception. So let's just copy that, and here we're going to put the index count is, and then it does these two checks first just to make sure if these counts coming in, like if we're trying to draw one single shape that has so many vertices that it's bigger than the whole array itself, we just want to throw errors, just say we don't allow that. But if the information coming in, if the vertex or index count isn't greater than the size of the arrays, but when we add that to the list, it takes us over the top of the size of the array, or makes it bigger than the size of the array, we need to flush the data and start over with batching again. Go ahead and ensure space, the shape index and vertex count. So we're going to make a shape vertex count is going to be 4. Since we are drawing a rectangle, we're going to need 4 vertices, and we're going to need 6 indices to tell the graphics card how to draw the triangles for this shape. So this will be the shape vertex count, and this will be the shape index count. So at this point, we've ensured we have enough space to draw this shape. So let's go ahead and start adding the information to the list. I'm going to try and break this problem down into a few steps here, and then maybe we can optimize after that. The first thing I'm going to do is figure out what the left side of the shape looks like, and that'll be the X. And then I'm going to get the right side of the shape will be X plus the width. Then we're going to do the bottom will be the Y, and the top will be the Y plus the height. Let's actually make the vertices. I'm going to say A, and again I'm following this pattern here. I'm going to call this one A, B, C, and D. So let's go back to our code. So A is going to be a new vector 2. That's going to be the left and the top. I'm just going to copy this and we'll make 4 vertices. So this will be B, C, and D. So the next one, B is going to be the top right. C is going to be on the right but on the bottom. And then D is going to be on the left but on the bottom as well. Now we have the actual vertex positions. Next, let's send the information to the array. Let's send the vertices now. So the vertices, we're going to increment the vertex count every time we add something to this array. This is going to be a new vertex position color. And this only takes vector 3s, so we're going to put in a vector 3. That'll be A and just at 0. So the Z component is just at the 0 plane. And it's always going to be at 0 for everything we do. And then we pass in the color. Okay, now we can just do this 4 times, one for each vertex. So we're going to pass in B, C, and D. That should get the vertex information. Now, the other thing we need is to pass in the index information. And let's go ahead and put that up here above. So we're going to pass in the index information first, and then we'll pass in the vertex information. So we need to define what each triangle looks like, because we're going to have 2 triangles, which means we have to have 6 indices. If we go back to our picture here, we're going to go 1, 2, 3, and then we're going to go 0, 2, 3. Let's bring up our indices. The index count will increase every time we add one, and so that's going to be 0. We'll put 6 of them in there. So we're going to have 0, 1, 2. So 0, 1, 2, and then 0, 2, 3. 0, 2, 3. That's mostly correct. There's only one problem with this, and if we always put 0, 1, 2, 0, 2, 3, we're always going to be pointing to the first 4 vertices. Oops, not that one. Okay, so we'll always be pointing here, no matter what. Even down here, like this would not be 4, 5, 6, this would be 0, 1, 2, 0, 2, 3. What we need to do, every time we're adding in new indices, we need to add in the current vertex count before we added the vertices. So here, the vertex count was 0. Before we added any vertices, vertex count is 0. So we're going to add 0 to each one of these. 0, 0, 0, 0, 0, and we end up with the same numbers. But once we've added now 4 vertices, here's our next vertex count. And so we're just going to add 4 to the next set, because that's our vertex count. And so the next set will be 0 plus 4, which is 4, 1 plus 4, which is 5, and 2 plus 4, which is 6. And then we're going to do 0 plus 4 again, 2 plus 4, and 3 plus 4, which is 7. So if we go back over here, let's go ahead and add in the vertex count. And we can copy that, because the vertex count will just be the same. This will ensure that these indices are pointing to the right vertices. We must add in the vertex count before we add in these new ones over here, these new vertices. Finally, I'm going to increase the shape count by 1. That should be everything we need for this shape. Inside the flush command now, let's go ahead and check to see if there are any shapes to draw. So if the shape count is equal to 0, we're just going to return because there's nothing to draw. Alright. Then at the end of this, we need to reset all of our counters. So the shape count will be 0, the vertex count will be 0, and finally the index count will be 0 as well. Okay, now in between here, this is where we're going to send the information to the graphics card to start drawing. In order to start drawing, I'm going to need a basic effect again. Now we could make our own custom effect, but I'm just going to use what MonoGame has provided for now, and we'll see if that's good enough for what we need to do. Since basic effect implements disposable, I'm going to implement that as well. And I'm implementing a basic dispose pattern because I'm not going to have any kind of native pointers or native values that would not automatically get disposed of by the garbage collector. We also need to have a boolean that questions is disposed. Set that to false. And let's set the effect. Okay, we're gonna need a little bit more room for that. So the effect will be a new effect. We're gonna need the graphics device. And then this is gonna be very basic. We don't need textures. We don't need fog. We don't need lighting. Let's give it the default. Let's just make sure everything's default here. The view and the projection. The only thing we need to make sure is actually enabled is the vertex color, because that's what's going to allow us to add color down here. When we have a color field for our vertices, that'll allow the color to show up. Now in dispose, we'll just check to see if it is disposed. Let's return. Let's dispose of the effect. And then set dispose to true. There we go. Okay, so very basic dispose pattern. I don't have any kind of unmanaged resources that I need to dispose of, so we're not going to worry about implementing the full dispose pattern. That should be good enough for our purposes there. We are beginning, we are ending. We need to tell the shape class what our coordinate system looks like. So if we go back to our sprite class, we can probably just take this code, yep, just like it's written here. We're going to copy this. No, we don't need the sprites, we just need the projection code. Let's put it in over here. That gives us everything we need to set up the correct coordinate system for drawing. And then inside of our flush, we're going to use the basic effect to draw the triangles that we're sending in. We need to loop through each effect pass. I call this the pass in the effect. There we go. We're going to apply the effect. And then we're going to tell the graphics device that we want to draw some user index primitives. We need to tell it what the vertices look like. And these are vertex position color. And then we just pass in all the information. So the first one is the primitive type. It's just a list of triangles. So a triangle list, which indicates that every 3 indices is a new triangle. All right, and let's go ahead. I'm going to drop this down over here so we get a little bit better view. Okay, so now this is the actual data. We're just going to pass in the vertices, the actual vertex data. The offset, we're always going to start at 0. The number of vertices will be the vertex count that we were storing early. Oops, if I can spell it right. Now we get into the index data. That'll be the indices. And it wants to know the offset. That'll always be 0. And then it wants to know the primitive count. So the primitive count is how many triangles are we going to draw. If we go back here, every 3 is a new primitive or a new triangle. So all we have to do is take the index count and divide it by 3, and that'll give you the number of primitives we're going to draw. Okay, that looks good. So we're sending the information to the graphics card, and we have the basic effects set up. We're resetting our counters down here once we flush the data. We've ensured started. I think that's everything we need to draw a rectangle now. Let's go ahead and give it a shot. Go back to our game class up here. Let's bring in the shapes. Pass in the game class as a reference. Now that we have that, let's just let's run this, compile this and run it, and let's just see if it works, if it gives us any errors or not. Okay, so far so good. We still have our old window here, and there's our guy moving with the arrow clicks. I'm going to change that window size, something a little bit more fitting. Okay, there we go. Down here, let's see if we can begin batching. And let's run that and see if the begin and end batching works all by itself. Okay, that's working just fine with no errors. Let's add, we have one thing we can draw, so let's try drawing a rectangle. Let's just start somewhere. Let's do 100, 100, so that'll be the bottom left corner of the rectangle, and then we're going to say, okay, here's the width and height. We'll just say 64 by 64, and we're going to make it black just to start. And let's see what this looks like. And I can see it right there. Let's move our face out of the way, and that looks correct. That should be 100 at point 100. 100 is right there, and then it's 64 wide and 64 tall. We can try some other arbitrary values just to see. Let's make it 16 by 128, so it's going to be really thin and tall. And there we go, that looks correct. And I'm going to shut off the sprite drawing code right now just to see what we're doing. Let's change the color to, we can do red. We can just test out the colors, make sure we get the color parameter correct. That looks right. How about a dark blue? Okay, that looks good. From last time, I defined an X coordinate that I was using to move my sprite. I'm going to set the X coordinate here to that and just see if I can move this around. There we go, and that looks good. That's working perfectly. Now the next thing we need to do is to draw multiple shapes. So let's put one at a totally different location. We're going to say like 400, and we're going to make this one really wide. So let's make it 2, 5, 6. And the height will be 32, and let's make a dark, is there a dark green? Let's try that one. So now we should be able to have two shapes on the screen. Okay, there we go, and it went off the edge of the screen. It was too wide to see the end of it, but that looks like it's right. We'll make this a little bit shorter, so let's just make it 64 and see what it looks like. And there it is. Okay, so it looks like we have the very basics of our shape drawing class working just fine. Close that down. Let's draw one more just to make sure everything seems like it's working. I'm going to put this one at 300, 100, and let's just pick some completely arbitrary 45 by 22. This is going to be a blue-violet. There we go. Okay, there it is. And I'm happy with these results. It looks like everything I wanted to accomplish here, and it seems like it's working just fine. We're also going to be drawing outline shapes, or shapes that just are made with lines. So I want to differentiate between the filled shapes and the non-filled shapes. And the way I'm going to do that is by the naming convention. So I'm going to call this draw rectangle fill. So if it has a fill at the end, that means it's going to be drawn with triangles and filled in. If it doesn't, it's going to be an outline drawn with lines.